Today, I want to talk about asking questions. More importantly, I want to talk about asking questions about data that we already have and making choices. As people interact with our sites, human or robot, most of the time we will take care to fulfill whatever request they send to us. But at the end of the day, there are good bots and bad bots. And in the case of bad bots, what we're really talking about is a case of asymmetric warfare. How many of you have a business where the sole business purpose is keeping malicious traffic and machine traffic out of people's networks? OK, great. So since that's the case unilaterally here, this is not your full-time job. You have a job to make money or provide a service or whatever. But the people who are doing the bad stuff, their full-time job is doing the bad stuff. And so it's not fair. Hence the title of this talk. It's not about how we scale as humans. It's how our robots can fight their robots. And that's really the point, is you want to make a robot that's capable of fighting the other nasty robots out there. But a point about robots first is that the internet is effectively powered by robots. These are the robots that are good. If you take these robots away, bad things happen to your search engine rankings. You don't want them to go away. You want them to be around. And actually, this is so important that we put together teams of people to manage them, right? SEO and SEM and all the other teams. These are very relevant teams. Most companies have internal teams that do this. Sometimes they're quite big. It's very important, especially when you're into the e-commerce space or other things like that, that you come up in the right places. So we employ teams of people just to manage these good robots. But on the darker side, not all robots are created equal. For example, is this request in a log file a robot or a human? Is it mechanically driven, or is a human clicking on a browser?
Robot.
Robot, why?
200 for post. No, I don't know. It's a robot.
It's a robot. I mean, it's a curl request, right? It's coming from a lower level API of some sort, probably just the curl command. But that one's pretty obvious. How about this one? Machine or robot? Sorry, yeah, machine or robot, right? Human or machine? Machine, why? It says wow. What does wow mean?
Windows on Windows.
Yeah. If you didn't know that, would anything else give it away? It looks like a fairly traditional browser user agent. If you Google it, it turns out to be a bot. The point is they're both robots, and it gets harder. As people fake user agents, people do different things, it gets harder. Some robots are more trouble than they're worth. And this is the most important thing, is sometimes it's not valuable to process this traffic. But first, how many of you actually know how much of your traffic is bot related? Anybody ever take a look and see how much traffic you got and is actually bots? Yeah, not many of us do this. For the couple of you that raised your hand, how much of it should be robot-related traffic versus how much you allow? I guess is the next question. So for those of you who didn't raise your hand about bot traffic, this question may be a little more relevant. Who here actually does testing and tracking? Experimentation, A/B testing, multivariate testing, that kind of stuff. I should see a lot more hands now, probably. For those of you who do that, or maybe you're just tired and don't want to raise your hand, how do the bad robots throw off your tests? Does that data ever mess with your testing and experimentation? Does it ever affect your results? Has anybody seen that happen before? Yeah. Yeah, they'll trigger the error. They'll blindly follow experimentation paths that will create noise that may look like something is working that really isn't. If you have a convergence model, it may take longer to converge because you're trying to filter out that noise. And eventually humans will win, but it might take a longer time to get the answer. And so even for testing and tracking stuff, it throws off analytics, throws off business intelligence. And then the last question is what are these bots actually doing on your site? Throwing off analytics is not what they're doing. They have a purpose, an intent of some sort. And gathering that intent is really important. But before we go too far, I want to talk about some common types of robots. and kind of classify them and talk about how we identify them before we go into the deeper details. The first and the most obvious stuff is spiders. Things that will basically visit links and crawl your site. Every link available, try to capture what's going on. Spiders are at the root of pretty much everything else we'll talk about. All the other types of robots usually have spiders associated with them to gather information. They use a set of scrapers and scanners to look for content, to find things. Sometimes people just use them on their own. In particular, things like the Googlebot, right? It's going to do that and figure out what the pages are and index them. Generally, they're trivial to build. Anybody can build these. You can download them. They're readily available, right? The how to build a scraper is basically a couple of steps. You go to a page, you gather the links, you put them in a queue, and you repeat until it's done, or until you've exceeded some kind of threshold. Spiders are incredibly easy to spot. Because they deviate from a typical behavior. They visit everything. How many of you have humans visit every page you have before they go away? Or I guess, how many of us struggle keeping the user on one page for more than 30 seconds? Yeah, exactly, right? Bounce rates is more what we're looking for here. They don't bounce, they just keep coming back for more. But they deviate really quickly from behavior. And more importantly, one of the biggest deviations that you'll see is the verb associated with the request. Most of the time, we'll have some breakdown, some distribution of HTTP verbs in our log files. This is a bunch of numbers that I think equals 100%. But the idea is that you'll have some distribution. You take a slice in time of all your traffic and sample it, and put this out, and then compare that against a single actor. If they deviate significantly, something doesn't add up, right? If it's 100% GET requests and that doesn't match your traffic, the spiders, they stand out really obviously, really quickly. So simply sampling traffic and looking at deviation catches a lot of activity really quickly. It's a super simple thing to do. It's cheap. It's effective. And more importantly, the idea of this talk is about thinking about how to ask these questions and then designing systems around them. I'm going to start with a bunch of simple stuff. Everything I'm going to talk about is pretty easy. It's just about combining it and making choices based on the information. Velocity, right? How often do they hit the site? Was it once every half of a second? It's probably not a human, unless they're really good at computing. But even then, velocity is a big indicator of this. Bad robots, bad scrapers, bad spiders, they're just going to hit as much as they can, as fast as they can, and then go away for later. They might come back with a different agenda later, but that's the idea. But on to scrapers. So scrapers are kind of an evolution of this. Once you see a spider, sometimes it'll follow with the scraper. But scrapers have intent. Scrapers want your data. They want to find out what's in the page. They want to save it. They want to download it. They want to do something with that data. It's important to them. There are ways to deal with scrapers. There are easy ones, right? The first scenario is if you have an API. You basically just stop them outright or send them to the API. Right? Say, hey, no, machines go here. Second scenario is you don't have an API and they shouldn't be doing this. Right? The answer is really easy. You just stop them. Say, sorry. The third scenario, you don't provide an API, and you should. Stop being lazy. But that's it, right? Like, when it comes to scrapers, they want your data. And somehow you haven't been able to provide them with a way to get your data, so they're probably scraping your page. Or they haven't paid attention, or too lazy to get your API docs and do it the right way. In this case, APIs are for machines, and web interfaces are for humans. If somebody wants your data, and you want to make your data available, that's what the API is for. Make sure you force robots down that path. Because what happens here is scrapers are dumb, and they're broken most of the time. And they might actually get the wrong data. So if you have affiliates, you have partners that want to provide and broadcast your information, and they're using a scraper, they might get the wrong data and produce the wrong content, and then mess with amplification of your ideas. If you provide them the data from the raw source, from the real source of truth, they end up getting it right and present it the right way down the road. So it's a win-win when it's done the right way. Right? If there's no reason for a machine in one scenario, or a human in other scenarios, you don't want to allow it. You just stop it. This is super important. A lot of us tolerate these robots, robotic activity, bad behavior, because it's not really affecting anything. They're not hacking you. They're not taking you out. It's kind of tolerable bad behavior. But it compounds over time and does really bad things. But you can squash this easily. Like I said, most of the time, scrapers are pretty dumb. This is enough to fool a scraper in most cases. Simply putting a comment in a page with a link, and then looking at whoever followed that link. Because if they follow that link, they're not human, because they didn't see it. They can't click on it. A scraper followed this link. So if you see this, this is actually good enough to throw off a lot of the scrapers that come around. Simple, it's stupid, but it's effective. Now, some of the newer kits that have come out that are designed for scraping pages, they have context aware and they'll deal with it. But start with simple. That little trick will reduce your bot traffic if you actually block that traffic, those actors quickly, pretty significantly right off the bat. But in this scenario, you have to accept that a small portion of intelligent actors will make it through. At some point in this battle, like I said, it's asymmetric warfare. You don't care about this full time. 100% is not the goal here. You want to get effective enough that you don't notice the delta anymore. The noise is reduced and you can keep moving on. That's the whole point of this. And the detection of this is similar to spiders, right? Scrapers are going to basically spider first and make the noise that way. But they're going to hit pages in a consistent order, and they're going to do a lot of GET requests. That's usually kind of the habit here, right? And in fact, like I said, a spider might precede a scraper just to figure out which pages it wants to look for. But that behavior deviation, which I'm getting on a theme here, is acceptable, right? The mechanism for figuring this out still kind of applies across spiders and scrapers. But then there's a more malicious category of robots, which is scanners. The idea of scanners is to be purely malicious. That's it. They want to try to actually break in. They're looking for vulnerabilities in your application. That's their purpose. They might have scrapers and scanners or scrapers and spiders built in, but they're looking for vulnerabilities in particular. They're also incredibly easy to spot. How many of you have done any payload inspection or logging on requests that come in, like post requests, that kind of stuff? Anybody look at that kind of stuff? What kind of tools are you using for that? Yeah. Are you looking at anything from a kind of malicious traffic detection system or anything like that at all? Examining the payloads for script tags or weird stuff like that? Yeah, I mean, these scanners are going to deviate from behavior, but they're going to submit obviously malicious data. You're going to look at it and you're going to see, a string of 50 million A's to see if they can, overflow something, or a script tag, or a single quote, or something that's going to signal to them that there's a problem here. And once they find that, they'll keep going manually and try to get through. But something that's more important is these scanners will look for URLs that they know to be kind of standard vulnerable default open URLs. So they produce a ton of 404s. So an easy way to spot scanners is look at the amount of 404s that a single actor produces or a single IP address produces. And they'll be off the charts for these scanners because they're just looking for things like phpMyAdmin and WP-admin, and like just trying to find what applications you have running behind your server, and to see if they can say, okay, great, it's running Plex, and I found this version, so I have this set of exploits, and go ahead and launch them, right? And that's how this works. You want to block these. Like, you just want these to go away. The asterisk here is important. Make sure that you talk with folks in your company, because sometimes your company will be doing this for real, legitimately, like trying to figure out if you have vulnerabilities. So before you just block all the scanners outright, you want to talk to your application security team or InfoSec team and make sure they don't have planned scans. Like you want to allow those through to make sure that that's tested properly. So you want to block everything but your own company doing this kind of stuff. The reason I asked about tools was web application firewalls can help here. They actually do this inspection at the web server level. WAFs are nice. I don't like them, but they're nice tools. I prefer running them in passive mode. Basically, passive mode says, when I see something, I'm going to let you know about it, but I'm not going to actively stop it. If you've ever seen web application firewalls pitched or sold, they are the silver bullet to all web application security, and it's a complete joke. What they are is regular expression matchers. And that means false positives. Lots and lots and lots of false positives. You will get those. You will block legitimate traffic if you turn them on and just leave them. They require lots of tuning. But more importantly, they tip your hand. So if I say and submit a form with script tags, and I say 403, forbidden, and then I do the same form and it doesn't block me, you just told me you have a WAF. And now I'm going to employ my WAF evasion techniques and just get around it. Because the other thing is, regular expressions are dumb. And you can accomplish the same inputs, but I just bypass that regular expression, because most of them are pretty weak. And so you don't want to tip your hand when you have the WAF. You want the WAF to signal you that something bad is happening, and behind the scenes be working on kind of just outright blocking them instead of showing them their hand and having them experiment until they get by your WAF, because you've given them that edge. And there's kind of an other classification. These are also malicious, but it's fraud, denial of service, espionage, that kind of thing. Fraud in particular is something that a lot of you, if you're running e-commerce sites, are going to deal with at some point in time. Denial of service is going to be a tough one. I'm not going to say anything about the volumetric denial of service attacks, like where they just slam you with a bunch of traffic and you go away. That's at a lower level. I mean denial of service attacks where somebody finds the slow pages on your site and just starts to load you up with with requests that way, right? And so they're taking you down via the application, not via the network layer. These still fall in the malicious category, though, right? They're doing something abusive, something malicious on purpose. But they behave differently. What these tools usually do is they have a focused target, right? They're going after credit cards. They're trying to, buy more things they should be able to do based on the rules. They have some kind of obvious agenda. It's like if you look at the traffic, they're obviously going after one particular thing and one only. So they're very pointed at what they're doing. And detection here is somewhat harder because you have to figure out what it is they're after. But once you figure it out, that pattern's super easy. Because like I said, they're always super obvious about what they're doing. And I'll show you a couple examples in a minute of what that looks like. And that comes down to kind of like what we look for. And in this case, there's one common pattern, right? The verb distribution was kind of a simple way to get going here. But there's an anomaly piece to this. We want to look for anomalies. We want to start with a null hypothesis and find everything that lets us reject that. That's what finds our anomalies. But this is the hard part. And actually, this is the most important part, is we first have to define normal. How many of you do log aggregation? How many have a query analyzer, some way to look at your logs? Not a lot of hands. You have to do that first, right? You have to have all your stuff in one place so you can see what's going on. Visibility is super important to all of this. So if you don't know what normal is, you don't know what not normal is. You have to define normal first. It's super important. And you have to know what has to change in order to be not normal, right? So you say, if these things hold true, we're all good, nothing is wrong here. But if these couple of things change, it's very important to act and figure out what this actually means. It doesn't mean it's bad. It means it's anomalous, and you want to figure out what it means more. And so here's a couple of requests, and I want to look through these and see if you guys spot the intent. We can talk about facts all you want, but we want to look at the intent of the request. So we'll have 4 requests, and then we'll kind of talk through it. The first request is a post / login. Has a user agent. We've already identified some things about this being possibly machine generated. But here's the first request. First request this address ever made. Second request is a post to users, king rule, and credit cards, the credit cards endpoint. Here's the third request. And here's the fourth request. So what did folks see here in that set of 4 requests? Trying to validate a credit card. Validating a credit card. There's a certain kind of attack associated with that called a carding attack, where people take a list of stolen credit cards and they see which ones still work. So we do a great thing for usability, where if somebody has an account on our system, we have them enter their credit card details ahead of time, and we validate them to make sure that when it comes time to check out, we can separate them from their money as fast as possible. Right? Impulse buys are the way of the internet. And so what we want to do is make sure that that friction is gone. And so this is a separate step to make sure that all future purchases are just kind of, one button, one click, whatever we can do, right? This service works against you in the form of these carding attacks. How many of you take credit cards online? E-commerce of some sort or another. How many of you are aware that this happens or have seen this attack before, right? If you haven't seen it, go look. Go ask your logs, you will find it. Pretty much everybody that accepts credit cards has this behavior. They're actually pretty good at flying under the radar as far as like the amount of requests they do based on your size, but most people will have this and just big credit card fraud rings looking for valid credit cards and selling them, or possibly turning around and using them against your site when they validated them, which is the other thing, right? So we've identified this as the carding attack, which we've explained what carding attacks really kind of are on the surface. But let's look at the request again. There's a bunch of stuff that makes us aware that it's an anomaly, right? The first is the login request should have been preceded by what? A GET request. We didn't have the GET request. We have a 200 here, that's all good. But the next request is, I'm sorry, actually, I was looking for, next request. We have a 1 second delay in our accounts, our requests. 1 second, 1 second, 1 second, 1 second, every one. I cannot type my credit card number and information in 1 second and hit submit. That's not possible. Maybe you have a form filler or whatever, but I'm going to say that's fishy. 1 second on the dot every time. We see that it's a Firefox 8 on Windows 7 is a strange combination of things. We've also identified that the Windows on Windows thing is another thing to look for, but the user agent is fishy. It's not quite, doesn't quite add up. And the next thing is super important too, geo-IP location, right? Where is this person coming from? If I told you this is a US company doing US-based business, it's a fictional company, but if I told you that information and you saw this request, you may start asking more questions, right? We don't normally see traffic from Bulgaria. What's going on here? Why is this all of a sudden popping up? And then finally, there's a bunch of 302s here that never get followed, right? Any standard compliant browser is going to follow the 302 when it gets it. That's how it's going to work. So we've seen a bunch of stuff that lets us know this is not human. And actually, more importantly, it's not a standards compliant browser. And so there's something fishy, there's something different about this. Now, we could go on the other facts here. This actually continues 10,000 more times. So then you're pretty sure it's a carding attack. The idea, though, is to spot it, identify the intent, and stop it before it happens 10,000 times, right? If you do it in the first couple of requests, life is better, right? Maybe they got to try one credit card before you stopped them. Okay, I mean, they could spend that out over 10,000 IPs in a day, and that's fine. But they're going to exhaust their pool of IPs before they do any real information. They're looking for volume. They have hundreds of millions of credit cards to test. They're not going to expend all of their IPs on your site if you can make it too hard. So it's about behavior deviation. How do we identify that? How do we isolate that? Right? And there are tips for this. There are simple things like velocity. How fast? If you look at how fast a normal user interacts, and then you look at the delta on a single actor, you can find it pretty quick. Every site has different patterns. Some people are clicking through pretty quickly. Some people maybe you have a big list of things to show, and people want to read it and look at it and see collections of things, right? At Groupon, we have lists of deals. You might spend several minutes looking through a single page just to see what deals are there. So velocity is important. If we see people click, 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 there's too much information on the page to warrant clicking that fast, unless they know exactly what they're going for. But that's not normal. The access patterns, the time of day. When is somebody doing the thing they're doing? If you have peaks and valleys of traffic, let's say you're a commercial service and doing lunch or something, and all your traffic comes at lunchtime, and then you see a big spike at like 2 a.m., that's not normal, right? That's something different. So access pattern also involves the path at which somebody takes to get to you. So this is where UX and security meet. A good user experience is actually one of the best things you can do for security. If you design a user to go down a certain path, it's really easy to figure out when they deviate from it. But if you have a bad user experience that leads people all over the place, you actually can't figure out when they're deviating from the standard common path. So go back and redesign your user experience to drive people down a common path. You'll see the deviations, they'll be way more obvious. So that user experience is super important. And how you drive your users to act on your page helps you figure out when people are just kind of moving off. Like I said, time of day is super important. Geolocation, this is huge. It goes back to access patterns, but where are people contacting you from? What's going on? You want to know where they're coming from, and really kind of time of day and geolocation is also super important, right? So if you're, like I said, back to the lunch example. If you're lunch in the central time, you're going to be looking at noon. If you're lunch in London, it's going to be a different time. So you want to match it up with lunch in whatever country you're serving. If it's off, if it's 2 a.m. in London, and you're looking for London stuff, you know, that's going to be the anomalous thing. So geolocation also comes into that time of day and access pattern stuff. So you want to see, you want to line that up. So it's multiple factors that come into kind of modeling this. Again, verb distribution was an example we already showed. User agent. So user agent's fine. But user agent's spoofable. I mean, anybody can put whatever the hell they want in the user agent header, and off we go, right? We don't really check that. It's not something you can trust. But you can combine this with other information, like the header order. How many of you have ever seen the actual order in which the headers come down from a browser? Anybody ever looked at that? Does it change? No, never changes. Every browser has a fingerprint. The order in which the headers come down is static for every browser. So if somebody says, I am Safari, and the headers don't come in the order that Safari comes in, it's not Safari. Just straight up, like that, it is a blatant lie. Now, it doesn't mean it's malicious, but it means that they're lying. Like, you can identify that almost uniformly in every single situation. And so this is a super simple trick to do. You can write a small little module for your web server that'll give you the raw order of the headers and then fingerprints it. And so you build up a little fingerprint database and just check it. Success rate. How often did the request succeed? Like I said, the scanners tended to throw this off pretty far. But you know, an example here, this IP address made 1,878 requests and had a 0% success rate. They were all 404s. This is not good. You want to block that, right? But you want to have these kind of statistics available to you, right? 403s, 404s, 500s, you know, 401s. They're all important. They're all relevant pieces, right? 500s are also a big giveaway. If you have a couple 500s, it means you got an error. If you have a couple 1,500s, it means they're probably trying to exploit something they found to see if that 500 could be, you know, dealt with in kind of nefarious ways. All this stuff, though, is surface stuff. We can go a lot deeper here. Because what we're looking for is really intent, we want to know what they're doing, why they're doing it, so we can kind of guide them off the right way. Or really, we want to figure out whether they're a robot or not. Actually, that's the whole point of this talk, right? Finding out whether they're a robot means examining how a robot thinks. A robot thinks and it behaves differently than a human. And we can play on that notion and actually make a robot tell us it's a robot by just asking it to do certain things that a human would otherwise normally do, or in this case, a standard compliant browser would normally do, and it ignores. It's been programmed to do a certain thing, and it will do that certain thing because it was programmed to do that certain thing. Like the 302, like following 302s, right? If it was never programmed to do that, it'll just keep going. And any normal compliant browser would just follow the 302. So we can actually kind of, if we're wondering, if we're suspect, ask the bot to do something that you know a human would normally do the right way, and see if it doesn't. If it doesn't, you identified a robot. And so we can basically push the bots to tell us they're bots by just asking them to do certain things. And ultimately, we have a goal, right? We want to block robots as quickly as possible. That's it. End of story. As few requests as possible, the robots go away, we move on with our day. It's not a core business. We don't really care at the end of the day. I want it to be an afterthought. I want to go look and see and make sure that everything's going on and the bots are being blocked, but I want to go back to business as usual. There are other things we can do if we go deeper. We can embed scripts in our pages that basically ask the bots to tell us about themselves. Actually, it asks everybody to tell us about themselves, but we're really looking for bot information, right? A small set of JavaScript that posts back to you can be correlated back with other traffic patterns to say, hey, what about this is significant? What about this browser, this user is significant? Now, that sounds fishy, right? Like you're doing tracking, you're asking questions. What you're really trying to do, the whole intent though, is find the bots. JavaScript does a bunch of stuff here. And there's one piece in particular that's actually great, the navigator objects. How many are familiar with the navigator object? Ever seen that before? Pop open your browser or your dev tools and go look at the navigator object, or just look at the docs on the Mozilla site. They're really good. For example, a couple of things we can ask. we can ask the user agent. So we could actually see what the browser says and what the actual header that comes down the stream says. And if they don't match, that's usually an indicator of something interesting. The screen resolution. How many of you ever run a browser one by one? If you see one by one, it's a dead giveaway that it's not a human, because we can't quite see that. But the dimensions are important. The platform that it's running on is important, right? It might say that it's Linux in the browser, and then the user agent says Windows on Windows. You're like, wait a minute, what's going on here? Or it comes back as Apple, right? You can also use Flash. Flash is kind of a dying breed, right? Flash used to be way more valuable here, but most people have Flash Blocker installed. Flash is kind of dying away. JavaScript is becoming more powerful, so I bet on JavaScript at this point, but you can still use Flash. But basically, the details make it easy to spot a bot. I mean, there's the one obvious thing. If it doesn't execute and come back to you, it's probably a bot, right? They might have JavaScript disabled, but then again, most of us don't have sites that work when JavaScript's disabled, so the user experience is pretty crappy anyways. But we can take a look, right? I talked about user agent before, right? See if it lines up with the user agent that was actually sent to you over the wire. The screen resolution, like I said before, was interesting. But there's other stuff. Cursor movement. The pattern of movement that the mouse makes. A human has normal patterns of moving the mouse. They're smooth. Even if they're fast, they're smooth. A cursor will track across the screen. Even if it's fast or slow, there's always a pattern. Robots, kind of headless browsers, or web drivers, don't do that. They just jump. The coordinates will just jump from here to here to here to here, because they know how to do the coordinates on the page. And the mouse movement will be so erratic that a human could never have possibly generated it. So you can look at the movement patterns on the cursor and see the deviation behavior, see that kind of fingerprinting. What plugins are installed? You can ask for the plugins that are installed. For most browsers, there's a default set of plugins. So it says that I'm Internet Explorer, and Internet Explorer has a default list of plugins, but it's like the plugin either come back empty or say, I don't know, some Chrome add-on, right? That couldn't ever possibly work on Internet Explorer. There's a mismatch. The fingerprints. The browser fingerprints are interesting, and they actually have gotten a lot better. Fingerprinting used to just be kind of like what's installed, what fonts are installed, hash. But now that stuff exists, and even down to details of load me the canvas object and ask a bunch of questions about canvas and WebGL, and there's fingerprints that happen even from inside of that. And so you also store the fingerprints of known bots. So once you've decided that there's a certain browser fingerprint that's bad, and you see that fingerprint again, you can go immediately to don't pass go and block them right away. Because those standard kind of like web drivers, the kind of things that really will return data, will always have the same fingerprint, to forever. There's an open source library from a user called Valve. This is not Valve the company. The user's name is just Valve. It's Fingerprint.js, and they also have something called Fingerprint.js 2, which is a kind of reworking. But it's kind of it's a great way to kind of get started and see how you interact with Navigator, how you interact with WebGL and Canvas and other things to give you that fingerprint availability. So I want to wrap up and give some time for questions, but a couple other things to remember is that we do employ teams of people to manage the good robots. This is a well-known practice. It's established. What we haven't done yet is building teams of people that manage the bad ones. It's important to actually build a team who can do this too, right? These bad robots are becoming so much more prominent as time goes on that their noise ratio is disruptive. Like the best cases, they're disruptive. The worst cases, they actually start breaking in and doing bad things. The carding attacks, the fraud, the abuse. It makes you look bad. It slows you down. It messes with your metrics. Otherwise, just causes issues. It's not healthy to allow this stuff. We need to make a system that lets us do this. Right? Detection is part of it. You want to be able to figure out who's doing what and when to block them, but you also want to be able to block them when it's time. If you ever tried to do this in a normal way, it means putting an entry in a web server or a load balancer and reloading the configuration. And so when that happens a couple 100,000 times a day or 10,000 times a day or actually just 10 times a day, and you have a couple hundred web servers, it kind of sucks to reload that over and over again. The best Ansible playbook in the world doesn't really make this pain go away, right? You have to have something more dynamic. You have to have a place you can look it up. And so there's an open source tool out there called Rapsheet that kind of does that. It embeds itself in the web server and Apache or Nginx, and uses an ephemeral cache for lookups. And so anything that you have behind the scenes can shove data into it, and it will quickly look up the information and decide whether or not to block somebody. So you can have that dynamic blocking. Rapsheet is just a couple, consists of a couple things written in C. It's an open source project under my GitHub account, or actually has its own GitHub org now, and I'll link to it later. But it's a small amount of C code that just takes a look at what's in the cache and decides whether or not to block somebody, and then does some logging and that kind of stuff. It's available as a web server module for Nginx and for Apache. There's a core library that they share in C. There's also a Java version of the lookup library that you can embed as well for if you're doing straight servlet stuff, not behind a web server. And down to the application environment, it's kind of that buffer before it hits your app environment. It can also trigger stuff down. But you have that slow out-of-band processing, you have external reputation feeds, you have other things, and there's a lot more I can get into. If you want to talk more about this, find me at the after party. I can tell you a whole bunch about how this stuff works. Because we are actually using it now. And we've actually built a bunch of visualization around it. So we can look at any point in time and see what's going on. What are the bad robots? What are we blocking? This is a picture, a capture, where you're seeing several thousand or 100,000 or million blocks in some cases. I mean, it's pretty easy to tell. The ones in the US on those corners are Amazon, the AWS. If you zoom in, you'll see just a bunch of AWS stuff. And actually, that's important to remember, right? The ASN of the request, right? Who owns the CIDR block that is contacting you is important, because it's pretty common that stuff from DigitalOcean and Rackspace and AWS and any of the VPS providers is going to be robotic traffic, right? People aren't renting AWS instances to computer, right? That's not normal. They have computers, so they don't need other computers to just do normal computing. It's executing programs. And so you want to think about that sometimes. Not that any of it's inherently malicious or bad, it's rented space, so anybody can do it whatever they want to it for a little bit of a price. And actually, those fraudulent credit cards that people validate on your site, they use those to buy time on the hosting company so they can never be tracked back and never get shut down. But ultimately, we want to reduce the noise. Bot detection is about reducing noise and figuring out what really matters for your business. You want to reduce the impact of attacks. If bots get driven away before they can really figure out a problem on your site, you're less likely to have kind of a drive-by vulnerability attack. So chances are you're going to have some kind of security incident down the road. But you don't want to get hit by the scanners, right? It's embarrassing to get hit by the robots and get hacked. And it shows kind of a lack of maturity. So you want to avoid that. You want to get those robots away. And of course, at the end of the day, good defensive programming and a good software security practice helps you do that. But you also want to make these scanners go away, right? The more they spot, the more vulnerable you end up becoming. And you want to improve confidence in your data. This business analytics, intelligence, testing, tracking, it means money. The faster we figure out how to convert, capture, drive interaction, the faster we get to the money. And at the end of the day, and I'm speaking on behalf of an e-commerce platform, but at the end of the day, when you're in that range, you want to drive the interaction and you want to know what works. And these robots throw that off for you. And so it takes you longer to find the money. And at the end of the day, that's really what matters. So I've got a couple references for you. GitHub.com/Rapsheet has all of the packages code available for the Rapsheet stuff that I talked about. And like I said, if you want to know more about that, I'm happy to talk at length about that later. The navigator object from the Mozilla documentation, that's the key to finding these kind of simple little scripts that you can embed in your page to do some checking analysis on what's going on there. The Fingerprint.js and JS2 are the libraries that I was talking about the basic fingerprinting. There are better tools out there. They're commercial services. I don't want to endorse anybody in particular, but you can go out and see fingerprinting services that are really good. They have big, giant, expansive networks of data. You pay per request, basically, so they can be pretty expensive. But there are some really good services that do this, and they're driven by a lot of really interesting science. And so I'd encourage you, if you really want to go down the way, if the Fingerprint.js stuff works, go and find those commercial entities that can help you out with that too, because you can get some really great data from that. And finally, we have some time for questions.